Good morning, Doctor. My name is Han Ching, and now our group will present about the project 123 that related to the air and noise pollution. We are group 2 from the section 1, and here is our group member, which is Ong Le Shuen, Dhurgashini, Tracy, Heo Ruoh Jau, and Han Ching. Now, I'm going to proceed with the project 1. For this project, we are choosing the Pahang as our location, where the Pahang actually is cover the area of 35,965 km², and the Romping, Temelo, Gerantot, Indera Mahkota Kuantan, Balok, Baru Kuantan are where the continuous monitoring station located and API value are recorded in Pahang. After that, for the data collection, we are entering the official portal Department of Environment, and we obtain the DOE dataset collection for air pollution index. And this data is from the 1st January of 2019 until 12th of July 2019, and the measurement conducted are per hours every day. Next is the API. The API, which is Air Pollution Index, is used as a standard in this project to assess the ambient air quality. This API can reflect the air quality effects on human health, and the PM2.5 is used to determine the API value. And the API consists of 5 levels, and as shown at the left hand side. The diagram shown in this is annual API graph for Pahang in 2019 for 5 continuous monitoring stations at 5 different districts. And the band chart is used since it is suitable for sketching of the API graph, and it could show both the reviewed air quality standard and the collected API data set by DOE. This is the API graph for the Temelo, Gerantot, and Indera Mahkota Kuantan. And from the graph, we found that the trend line for the API value at the Temelo, Gerantot, and Indera Mahkota remain at a good and moderate level in 2019, which indicate low and moderate pollution that actually does not pose any adverse effect on human health. This is the API graph for the Balok, Baru Kuantan, and the trend of API show that most of the time the API are at the good and moderate level. However, it is detected at unhealthy levels by continuous air monitoring station with API value greater than 100. For instance, the API value at unhealthy level was detected from 19 March to 20 March, where the highest value achieved 161. And moreover, the API value at unhealthy level was detected again from 19 April to 24 April. This indicates the ambient air quality start to threaten the health condition of the risk population with lung and heart complications. Last but not least, this is the API graph for the Romping. The trend of API show that most of the time the API value are at good and moderate level. And however, the API that greater than 100 are detected from 15 March until 20 March, showing the air quality at unhealthy level. And during this period, the trend of API from 16 until 18 March are even reached to the unhealthy level. The unhealthy level of API indicate that it's able to affect the public health and even threaten the health condition, and has a low tolerance for physical exercise for population with heart and lung complication. Apart from that, from the graph, we also found that the trend of API from 11 May until 12 May was detected to exist 100 and show an unhealthy level. And that's all for my part. Thank you.
Good morning, Doctor. My name is Heo Ruoh Jau, and my metric number is AN200201. And now I'm going to proceed the discussion summary. On March 15, 2019, the air quality in Romping was getting low at 11 AM. And the API value raised to 103, which is categorized as an unhealthy level. On March 16, the API reached to a highest value of 283, which is categorized as a very unhealthy level. Besides, the air quality in Balok Baru Kuantan reached the range of 120 to 160, which is categorized as the unhealthy level on the 19th March. The Pekan in Romping has been experiencing a 6-hectare forest and bush fire since March 11. The haze had mainly shrouded the area in Romping. Besides, the strong wind and ongoing hot and dry weather hampered the effort of the fire and rescue department, and hence worsened the air quality around the area. Air pollution and weather are linked in a way that concerns the influence that weather conditions have on the dilution and dispersal of air pollutants. Besides, the forest fire in Pekan, which has not yet been put out, was the major cause of the deteriorating air quality in Balok Baru, Kuantan. Based on a standard air quality status indication released by Air Pollutant Index Management System (APIMS) under DOE, the API value in the range of 0 to 50 indicates that the air quality is in good condition, while the API range of 51 to 100 reveals moderate air quality. However, the air quality is considered as an unhealthy level when the API value reaches the range of 101 to 200, while the API value in the range of 201 to 300 represents a very unhealthy air quality that is a kind of worrying situation. Doubtlessly, the air quality reaches a hazardous level when the API value is 300 and above. When the air quality reaches an unhealthy level, the sensitive group may experience eye irritation and runny nose due to the heavy air particles in the atmosphere and nasal irritation, which stimulated mucus production. Besides, people who were with heart and lung complications in Rompin had minor chest pain and breathing difficulties during the period. They were easier to get coughing than the other periods due to the throat irritation caused by the haze, which led to mucus discharge that can clog the respiratory tract. The air quality that reached very unhealthy level consequently caused aggravated health problem symptoms not only shown on the sensitive group but the public as well, such as breathing difficulties, headache and dizziness, and bronchitis. The keep rising API also decreased exercise tolerance, decreased lung function, and depressed respiratory immune defenses for those who stay in Rompin and Balok Baru, Kuantan. The high concentration of PM 2.5 in the atmosphere resulted in hot and dry weather as well. The Ministry of Natural Resources, Environment and Climate Change (NRECC) has implemented a variety of initiatives to combat the haze issues. Strict legal action will be taken against people who conduct open burning on construction sites, industrial zones, and plantations. NRECC utilized 3 mobile air quality monitoring systems and 65 continuous air quality monitoring stations to continuously monitor air quality and detect changes in air quality status. NRECC also plans to conduct ground and area monitoring to identify and supervise any fire breakdowns that might have impacts on Malaysia's state's air quality. Besides, the public could have done some extra steps to mitigate the particulate matter emission. For example, take public transportation more often instead of driving, eliminate or abandon the usage of wood stoves and fireplaces, inhibit burn garbage, yard waste or idle items, use electric or battery-powered lawn and garden tools instead of gas power. And that's all for Project 1. Thank you.
Good day, Doctor. My name is Ong Le Shuen, metric number AN200213, and I'm going to present about the Project 2, which is weather forecast in Malaysia. First, location of project. Our project is located at Ipoh, Perak. Ipoh is a northwest city in Malaysia with an area of 643 km square and an elevation of 22 meters. 2.2 Data collection. The data for date, wind direction and wind speed within the 2 weeks duration, which is from 11th of January to 25th of January for the year of 2023 was recorded as shown in the table. 2.3 Results and calculations. The data collected on the table previously is then summarized by using pivot table. The data of speed and count of directions are selected to generate the table. Then the table is rearranged according to north, northeast, east, southeast, south, southwest, west and northwest direction in ascending order. Radar chart for annual wind rows. All the data except for the grand total in pivot table is selected to conduct the annual wind rows radar chart. Bar chart for distribution of wind directions. Besides, to analyze the distribution of wind directions, the wind directions and wind speeds data can be represented using bar chart. To conduct the bar chart, the wind direction and the data for grand total of each directions are selected. Bar chart for distribution of wind speed classes. Moreover, the wind speed distribution can also be represented in the graph. In this case, the wind speed and the grand total for each speed are chosen to perform the bar chart. Lastly, in order to build a windrows diagram for the selected place, which is Ipoh Perak, 360 degrees, which represents the whole degree of a circular model, is divided by the total number of wind direction, which is 8 directions. Then we get 45 degrees. That means for every 45 degrees, the value of 4 km per hour and 7 km per hour wind speed, along with the grand total for each wind direction, is recorded by using the same value. The values are rearranged in accordance with the direction, and then the windrows diagram is conducted using the radar chart. Windrows diagram at Ipoh Perak. Then the windrows diagram conducted is placed at the map obtained from Google Earth located at Ipoh Perak. 2.4 Analysis and Summary. For wind speed at 4 km per hour, most of the wind blows at north direction, which indicates that there may be a northeast monsoon present in Ipoh from 11 to 25 January of the year of 2023. The northeast monsoon generally occurs from November to February and may bring heavy rain, typically to the states on the east coast of peninsular Malaysia. Considering the wind speed at 7 km per hour, the wind blows at south and west directions are the highest. The wind from south and west direction may be due to the southwest monsoon, which is considered a prevailing wind flow in Malaysia and will causing a relatively dry weather. According to the bar chart showing the distribution of wind speed classes, the wind speed normally is around 4 km per hour, but sometimes rise to 7 km per hour. This phenomenon occurs because of the wind speed, which is directly proportional to the pressure gradient. The pressure gradient at the survey location may increases at that time, causing the wind speed to rise from 4 km per hour to 7 km per hour. Last but not least, from the data collected, we can observe that the wind with 7 km per hour speed mostly occur at 3 am. The phenomenon can be further explained by the cycle of daytime heating and nighttime cooling. At sunset, the Earth's surface and the layer of the atmosphere directly above it cool faster than higher layers of the atmosphere. Therefore, higher winds are usually confined above the surface at night. Conclusion. In a nutshell, reading the wind direction is simple, intriguing, and not complicated. While participating in favorite sports and outdoor activities, this highly practical skill can be applied. For instance, when executing some wind-related sports like surfing, windsurfing, kitesurfing, fishing, sailing, or paragliding, it is significant to check the wind forecast in Ipoh when searching for the best travel destinations. And that's all from me. I will pass it to the next presenter.
Hello everyone, my name is Tracy Sambai Anak and I will do the introduction for Project 3. For introduction, the Tox Flame program is based on an elliptical solution to the atmospheric dispersion equation for inert substance having a density similar to air and a tendency to experience first-order chemical or physical degradation. Concentration could be exposed to the model for a set amount of time or continuously. Tox Flame can compute the extent of pollution plumped due to mechanical or thermal momentum in addition to modeling the discharge from a point source. Stack or pool fire are considered point source based on a vertical profile that takes into account both the characteristic of the topography and atmospheric stability. Toss flame extrapolate the wind speed at the release height.
Salam sejahtera and good morning, doctor. My name is Dhurgashini Dewi, Anak Bala, metric number AN200202, and today I will present on the Google Earth data. So basically, this is the data that we have obtained from the Google Earth, which consists of 5 parameters, which is wind direction, wind speed, temperature, mixing height, and also the Pascal Gifford stability. In this project, we are required to change one parameter at one time, while the others are fixed for each case. So from this, the first diagram, which is the wind speed, unit is meter per second. There are 5 samples that is taken altogether, and the parameter that change is the wind speed, which is 1, 2, 3, 4, and 5, according to its color, which is red indicates the low concentration of pollution, green is the moderate concentration, and blue is the high concentration of pollution. And the data taken from minimum interval to maximum interval. And this one is the wind direction, which is the wind direction is 72 degrees, 144 degrees, 216 degrees, 288 degrees, and 360 degrees. The next one is the temperature. Also the same, sample of taken is 5 together. The temperature is changed, which is 6 degrees, 12 degrees, 18 degrees, 24 degrees, and 30 degrees. And the data is taken. And the next one is the mixing height. The mixing height unit is in meter. So we have obtained 5 samples, which is in 200 meter, 400 meter, 600 meter, 800 meter, and also the 1000 meter. And the last one is the Pascal Gifford stability, which is there are 6 samples altogether, from A to F, and its color, which we can see from the Google Earth image, and also its data, which is the minimum interval to the maximum interval. And that is all from me. Thank you.
Next, I will proceed to discussion why it relation of wind speed to concentration of pollution. The relationship between concentration of PM10, chloride, sulfate, tetrate, organic and inorganic carbon, particle number, and NOx and wind speed. The easiest way to explain the data is to use a general dilution term multiplied by up to 3 different sources related term, which we interpret as standing for long-range transport sources, discrete local sources including aerial sources and marine sources, respectively. Using this method, the contribution of the 3 sources category may be quantitatively separated from the different particle measurement. The unusual behavior of nitrate is likely a result of the effect that wind speed has on the dissociation of ammonium nitrate. The link between airborne concentration and wind speed has been qualitatively observed by authors of several searches of airborne gases and particulate matter. However, there are a few quantitative investigations of the impact of wind speed on aerosol concentration, with the expansion of marine aerosol formation and wind-induced suspension from the land surface. Although in rare situations a rise of concentration may be seen at the general wind speed, it has been extensively documented that for the majority of airborne particle and gas measurement, concentration decreases as wind speed increases. For discussion relation of wind direction to concentration of pollution, knowing the direction of the wind can assist identify the origin of air pollution, enabling more educated choices to better safeguard both human and environmental health. Stronger wind locations often have lower air pollution concentration due to increased air pollution dispersion caused by higher wind speed. The air often becomes more turbulent during the day as the earth warms up, which causes air contaminant to the scatter in the air. Because circumstances are steadier at night because the air is cooler, contaminant have a tendency to spread less. The wind disperses the air pollution brought on by both natural and man-made activity. Next, for relation of temperature to concentration of pollution. How soon a chemical reaction takes place might depend on a variety of factors. Some of these components can be changed to change the response speed. Some of the factors that affect the rate of the reaction include surface area, temperature, concentration, and the presence of catalytes. Our primary concern will be concentration and temperature. Before two particles may interact, they must be first collide. Additionally, a specific amount of energy must be present in the colliding particle. The speed of reaction will likely increase with any factor that might make collision more likely to happen often or increase the energy of the particle. For relation of missing height to concentration of pollution, it was found that the level of air pollution and the missing height did not always correlate. Missing height show a weaker correlation with the greatest oxidant concentration than other variables such as temperature at different altitude, the oxidant concentration from the previous day, the height and the temperature of the inversion base and top, geopotential height and pressure gradient. The strongest correlation with missing height was shown for the greatest CO concentration and other variables, including the inversion base height, the CO concentration from the day before, the temperature at various height, pressure gradient, and geopotential height. Lastly, relation of Pascal Gifford stability to concentration of pollution. Although a Pascal method was developed to explain this dispersion situation and was never intended to be a standalone measure of stability, it has been utilized to characterize stability in a number of applications unrelated to air dispersion. In this study, we examined the method underlying assumption to see whether they are strong enough to describe stability and whether it's really usable characterization when used as a stability classification tool outside of the content of the air dispersion.